If we're going to study psychology as a science, we have to understand the methods that psychologists use to study the mind and behavior. There are different methods, and let me just describe what they are now. First, there are descriptive methods, such as naturalistic observation. We simply observe behavior as it's occurring and make conclusions about those observations. For example, the primatologists Jane Goodall and Diane Fossey are well known for the work they did in looking at gorillas and chimpanzees and trying to understand their behavior by simply observing them in their natural settings. This is often used also in educational settings to look at how children interact with their environment in an educational setting. We simply observe them, and then from those observations, draw conclusions about what's really happening in the natural setting. Naturalistic observation. Another are surveys. How many of us have been in a shopping mall when somebody comes up to us and says, how about filling out this survey? It's usually anonymous, and it's usually just to get a snapshot of people's opinion about something. Surveys are used widely in election polls, in marketing studies, in dealing with trying to get people's feelings about some particular thing. And then finally, there are case studies. This is where we observe the behavior of unusual and particular kinds of people. I'm going to talk about 3 different case studies. The first is Luria, the Russian neurologist Shereshevsky, or S as he called him in the book. It's a great little book. Let me just get to this. A great little book called The Mind of a Mnemonist by Luria, where he describes the unbelievable memory abilities of this person that he found working in a Russian factory. Just for an example, in the book he describes an experiment that he did with Shereshevsky. He showed him a 15 by 4 matrix of numbers, single digits, and told him to learn them. And Shereshevsky looked at the number array, and after about 3 minutes he said, okay, I've got them. And then Luria would say, well, give me the numbers. He says, how do you want them, backwards and frontwards? And he never made a mistake. He recalled every single one of those digits. And if he said, well, give me the 3rd column, he would recite the 3rd column of the digits. He had memorized in a very quick fashion a lot of things. And he was just like that. He said his problem was not remembering, his problem was forgetting. The second one is Brenda Milner and other psychologists in Canada, HM. HM, we'll talk more about HM when we talk about memory, but he also was a interesting memory phenomenon, except when he was young, when he was a teenager, they actually went in to cure epilepsy, this very radical spreading of activity across the brain, by cutting off both of his temporal lobes, called a bilateral temporal lobectomy. And when they did that, it actually stopped his epileptic seizures, but it also created the consequence of his inability to learn anything new. What he learned prior to the operation, he understood and he knew, but he couldn't learn any new things. Every time the doctors who he knew before the operation, he knew who they were, but if he had a new doctor and they came into the room, every time they came into the room, they had to introduce themselves. So he just couldn't learn anything new. Inability to form new long-term memories. And then finally, a very famous case study back in past centuries was Phineas Gage, who was a worker on the railroad, and while he was tapping in some explosives to create the railroad, there was an explosion, and a tapping rod that he was using actually went through his eye and out the back of his head. In fact, here's a picture of his skull showing the rod going through the skull. It really damaged severely parts of his frontal lobe and the brain, and people studied the changes that this occurred. By the way, he never lost consciousness when this happened, so it's an amazing phenomenon. Personality changed. His frontal lobe, he couldn't make easy kinds of decisions. But again, it's an example of a case study where something happens to somebody, the bilateral temporal lobectomy in HM, the rod through the head, through the brain of Phineas Gage, And we study and understand how the brain and behavior work by looking at these particular case studies. So the first we've been talking about are descriptive methods: surveys, case studies, and naturalistic observation. The third measure are correlational studies. Correlational studies are variables looking at how variables relate to each other. We measure one variable, we measure another, and we look to see how they relate to each other. We take a statistic called a correlation coefficient, which is the way in which these relate to each other, and it goes from a positive 1.0 to a negative 1.0. This is, for example, a correlational study. You can see the individual measures that we make. They clearly are related to each other. In fact, the correlation coefficient is 0.81, saying that they really are highly related, close to 1.0. And it might be something like SAT scores and performance in the first year of college. That's a positive correlation from 0 to 1.0. A negative correlation would be from 0 to minus 1.0, which means that as one variable increases, the other variable decreases. Correlational studies. Now, in correlational studies, we have to understand that we cannot get causation out of correlational studies, and yet it's very common to see an inference made about causation when you only have a correlation. Here's one I took out of the newspaper: those who cohabitated less enamored by marriage. In other words, you have weaker marriages if they live together prior to their wedding. But the inference, and I just said it that way, is that one causes the other. By cohabitating, it causes weaker marriages, when in fact what they have is a correlation. And there could be other variables, many other variables, that actually could have caused the weak marriage. Correlation does not imply causation. Now, the final method I want to talk about is the experimental method. And the experimental method is designed so that you can look at causation. And it's the most important variable in a group of different methods that we can use to study the mind and behavior. First, with the experimental method, we control all variables and try to manipulate just one at a time, removing all the confounding variables. The variable that we manipulate is called the independent variable. So we manipulate an independent variable to look to see what happens in behavior in the mind, and that's called the dependent variable. So in psychology, the dependent variable is always behavior. It can be behavior of the brain. It can be actual behavior as we do things, because that's what psychology is. It's a science of behavior and the mind. So we manipulate an independent variable, make sure there are no other variables that can confound that, and we measure the dependent variable, the behavior that we're interested in. So the only way to determine causation is with the experimental method. Now, there are some sophisticated correlational techniques, very sophisticated statistical ways in which we can get some ideas about causation when we're simply measuring lots of variables. But the way we really want to look at causation is with the experimental method. So here we have the components of the experimental method. We first look at the research literature, have some practical problem that we want to deal with, or we make observations about behavior, and we come up with an hypothesis, a research question that we're going to test. The hypothesis is often a prediction about what will happen when we manipulate the independent variable and measure the dependent variable. So once we have an hypothesis, we make our manipulation. We take an independent variable, making sure there are no confounds with other variables. We manipulate it, and we look at what happens as we manipulate it. And if that manipulation causes a difference, we want to see whether or not that difference is significant or not. So we do some data analysis. We say, is that a significant difference? Or is that a difference that's simply due to chance? And with statistics, we can make that determination. And then based on what we find in the data after the manipulation, we make conclusions. And those conclusions then will feed back into the research literature, or we solved a practical problem, or we can make observations about those conclusions and come up with more manipulations that we can make. The experimental method, the way we look at causation with behavior. So today we talked about several different kinds of methods. We talked about descriptive methods, that simply give us a snapshot about what's happening. We talked about case studies where we study extraordinary individuals to try to draw some conclusions about the brain and behavior. We look at correlational methods where we look to simply look at whether things are related to each other, either positively or negatively. And then we talked about experimental techniques, that powerful tool that we use to look at causation. So that's it for methodology. Thank you.